Under normal conditions in the atmosphere, temperature decreases with an increase in altitude. The graph shows an increase in temperature on the horizontal axis and an increase in height on the vertical axis. Under normal conditions, as you increase in height or altitude, the temperature starts to decrease. Under these normal conditions, your warmer air is typically found closest to the Earth's surface, and with an increase in height, the temperature then becomes colder. However, during an inversion, the normal conditions are reversed. If under normal conditions, temperature decreases with an increase in altitude, inside an inversion layer, the temperature increases with an increase in altitude. In simple terms, inside the inversion layer, the higher you travel into that inversion layer, the warmer the temperatures become. Looking at the graph, you will notice that initially there's a decrease in the temperature with an increase in altitude, and this represents normal conditions. However, once the inversion layer is reached, there is an increase in temperature with an increase in altitude, and once you pass through the inversion layer, normal conditions prevail where there is a decrease in the temperature with an increase in altitude. Ensure that you know the definition of what an inversion layer is. There are two possible ways in which you could define an inversion layer. It could be described as a layer of air in which the temperature increases with an increase in height or altitude, or you could also say that it is a layer of warm air with cold air that is trapped below it. This inversion layer plays an important role in the rainfall patterns experienced over the interior of South Africa in winter and in summer. The position of the Kalahari high pressure cell over the interior of the country has an influence on the height of the inversion layer, and this in turn has an influence on whether the interior of the country receives rainfall or not. During winter, the Kalahari high pressure is closest to the Earth's surface, which means that the inversion layer is also closer to the Earth's surface, which in effect blocks any moisture from the Indian Ocean moving onto the interior to create rain. However, due to its vertical movement and surface warming during summertime, the Kalahari high pressure is pushed higher up into the atmosphere, which means that the inversion layer is higher above the atmosphere, and this will allow for moisture from the Indian Ocean to flow onto the interior of the country to create rain. This inversion layer is created by subsiding air or sinking air that's associated with the Kalahari high pressure, and when this air sinks, it warms up and becomes compressed to create the inversion layer that is associated with the Kalahari high pressure cell. Just a reminder that the Kalahari high pressure, like all other high pressure cells, is characterized by sinking air. That sinking air warms up as it sinks towards the Earth's surface. Once that sinking, warming air becomes compressed, you have the formation of a temperature inversion, and in this layer of air, we're going to find that the temperature increases with an increase in altitude. However, the air below it is slightly cooler. During the South African summer, we find that the Kalahari high pressure has moved high up into the atmosphere. Therefore, the inversion layer forms high above the escarpment of South Africa. In this case, it would be the Drakensberg Mountains along in the eastern part of the country. Because the temperature inversion has developed high above the escarpment, warm, moist air from the Indian Ocean is able to flow across the escarpment and onto the interior of the country, and this warm, moist air then provides the necessary moisture for rainfall to develop over the interior. In short, during summer, the Kalahari high pressure is high up into the atmosphere. The temperature inversion is high above the escarpment. This allows for warm, moist air from the Indian Ocean to flow onto the interior, and this then provides the rainy conditions required for the thunder showers over the interior of the country during summertime. During winter, however, the Kalahari high pressure cell moves closer to the Earth's surface, which means that the temperature inversion also develops closer to the Earth's surface. In the case of winter, the temperature inversion rests on the escarpment to the effect that any warm, moist air coming off the Indian Ocean traveling up the escarpment is able to penetrate through the inversion layer, and that moist air is trapped along the coast. This prevents any moisture from going onto the interior and thus helps with the development of these dry conditions over the interior of South Africa over the winter time. So during winter in South Africa, the Kalahari high pressure is closer to the Earth's surface. This allows for the temperature inversion to also develop closer to the Earth's surface, resulting in it resting on the escarpment. The temperature inversion then blocks any moisture from the Indian Ocean from traveling onto the interior of the country, and this in turn is responsible for the dry conditions we do experience over the interior of the country. Just a word of caution to the candidates in the Western Cape, because we often receive our rainfall during the winter period. Please do remember that the rest of the country generally does not get rainfall during winter. So when we receive winter in the southwestern Cape, the interior of the country does not receive any rainfall